Uh, my name is Ricardo Salveti. I'm leading the, as we call, as the developer platform group Linaro. I'm going to talk a little bit more the work that we do and as the main platform that we use as Ubuntu and all the work that we did on pushing things and improving Ubuntu and making Ubuntu better on ARM in general. So some of the topics that I'm going to cover today is basically I'm going to discuss a little bit about the history of Ubuntu on ARM, showing how the project started and how it was until Linaro came up in the picture. The problems that we faced initially before working on it in Linaro and the things that we planned to fix in Linaro. Talking a little bit more about Linaro itself and what is the idea behind Linaro, what kind of work do we do, and why we choose Ubuntu as our main developer platform, like the usual GNU Linux platform. Going to cover a little bit more about the work that we did, like showing what kind of improvements we push it to Ubuntu, and also some future development that we're probably going to cover in the next few cycles. Linaro cycles, we have what we call the monthly cycles nowadays. So the first thing is showing a little bit more about the early days of Ubuntu on ARM, how the project started. It started in 2008 in collaboration with ARM. We had a few ARM employees also working with us, trying to fix some of those issues that we have, even on the compiler level, on the application level. Initially, the goal when we started the project was to get and to have like the most optimized ARM distribution around. And at the time we had a bunch of other distributions, but we have, for example, Debian was mainly supporting ARMv5, so we want to go a little bit further as we started to see and use newer devices, like, for example, the Beagle board and even OMAP3, that would be an ARMv7 with a few others pieces that would be important and would be useful to use, like Thumb2 support and Neon and a couple of other things. So to start, the initial goal was basically to have something working and have a release that would be able to boot on those ARM boards. So we basically derived from Debian as usual. And we make just a little few modifications and got everything in place in the archive, rebuilt the whole archive for ARM, but using a v5 as the first target. And the first release, the first official ARM release for Ubuntu would be the John Triclop, the 904. And initially it was supporting basically the X51 boards. We had also a partnership with Freescale at that time. They would provide us the board that would also work with us, because at that time we didn't have like this main and upstream kernel that would easily work with that board. So it was more like a BSP-like kernel that Freescale provided for us. Then we integrated and make those available in our images. And when we started, one of the goals and the targets was to make it available for what we call it as the internet tablets, like the A900, A800, and also a few other netbooks that was going to come in the next few months. So that was the initial goal. We'd also like to provide, like, for example, Ubuntu on this kind of platform as I'm going to show later, the interface is what we call as the netbooks, Remix, and a few other things. Differently than the other distributions, we didn't support cross-compilation. All the builds that we had were all native, and we enabled a bunch of MX51 boards at our at Launchpad and our build farm. And we rebuilt all the archive based on using native builds only. So it took quite a while, and it was a lot of work to make those work and the cross build in the first instance. So that's why we started working with native, because it would be easier for us, at least from an Ubuntu perspective. It would take a lot more time, and a lot of them are builders and such, but it would be easier at the beginning. And most of the things that we did during this release were packaging fixing and bringing up the images and setting up the archives. So it was more like an infrastructure project at that time. Then the second release that we did that also supported ARM was the Carmicola, is the 910, and at this release we started to look a little bit more in the future and try to optimize it a little bit more, like trying to enable ARMv6 with VFP instead of just supporting ARMv5. As this was the default option for Ubuntu, we stopped supporting those ARMv5 boards that we supported on the previous release. So, and then if you would like to keep it supported on a Debian-based distro, you would probably just keep using all the other release or move it to Debian, because Debian is still supporting ARMv5. And then the third release that we did was the Lucid Lynx, the 1004. This release was a major change for us because we started to optimize and compile most of the packages for ARMv7 with Thumb2 support and optional Neon support as well, and a couple of libraries, because we didn't want to force Neon by default, because Neon was not part of the ARM, the Cortex-A8 specification, so we could have boards without Neon, as we had later on with Tegra 2, for example. So what we did was we tried to enable Neon as the most we could, but most of the time doing runtime detections to avoid having incompatibilities with boards that didn't actually support Neon. At this time, there was a lot of work porting going on to make it compatible with Thumb2. There was a lot of issues, a lot of compiler ICEs all around, and quite many fixes that we did to do over that cycle, but we were finally able to release, and it was the kind of first real optimized release for the newer ARM boards that we had at that time. And we also added support for the Beagle board, because Beagle board, I think it started a little bit before that, but we didn't have it as an official target. So then we started producing real Beagle board images for people to use and consume. And as to bring up like a fast interface, because at the time we were using the GNOME Classic interface for the main desktop, and that was it was kind of heavy, it was kind of slow, and when we started using with this, for example, Beagle board and such, because it had 256 megabytes of RAM, and it was kind of a little bit slow. So then we decided to create a newer UI that would be the default for the ARM images, and then we created what we call as the Netbook Edition. It was an LF-based interface because it was quite fast for this kind of devices. And then we could also start shipping like X51 based products and boards. We have a picture of one of the boards that one of the products that were using this latest release. This was the interface that we had at that time, based on EFL, and this is an X51 based netbook, and you can easily find on this is an Africa Smart Book, and you can easily find, you can buy online if you want. And this was I think the first product that we start shipping, and that would basically support our initial goal. That would be to have like fully optimize it and for ARMv7, and with a good interface that didn't have this slow feel when using it. And that was basically the status once before we started Linaro. So we had a bunch of things already. It was working for the ARMv7 boards mostly. It was kind of optimized. It was still not fully optimized. It had a bunch of different problems with the porting. I'll discuss more about that and how we try to fix on Linaro. For example, when you go and look for what kind of the problems that we faced at that time, as we had different images for different boards that we supported. And we didn't have, like, for example, as we have for x86, it's just like one live CD or one image that could boot on any laptop or any x86 based board and machine. Because each kernel had its own different support, and one kernel didn't actually boot on the other target, as something that we also working in internal Linaro is try to have this one single Z image support across different architectures. And there was a lot of work maintaining the kernel trees as well, because most of them were kind of BSP based and provided by the vendor. Like, for example, the Freescale used to provide us a BSP kernel that was, I think it was older than that we were using by default on the Ubuntu release, but had most of the things enabled there. And we had a different BSP for each vendor that we supported at that time. So that's kind of a pain in the ass later on when you're doing stable updates, when you're supporting. Because on Ubuntu, once we release something as official release, we need to support across 18 months. Or, for example, the LTS that's going to be released now, the precise pangolin, is going to be the first LTS for ARM that also supports ARM. So it's going to be like 5 or 6 years for the desktop. And so it's a pretty long time, and we want to make sure that we're not stuck with a BSP-based kernel, because then there's going to be a lot of pain to maintain those later on. And all the work that we needed to do, for example, for the kernel side, any backporting, any new feature that we would do, for example, APRM or a few other things that are important for Ubuntu, was pretty hard to actually support on all the different kernels that we were shipping at that time. And it was also hard to work with the most embedded developers that we had at that time, because we didn't have like a real focus. We were trying to ship like the normal desktop, and we were also calling ourselves as kind of embedded, but we didn't actually fit on any of those any of those hours, because it wasn't embedded enough. Like, it was pretty heavy, pretty huge. And it wasn't actually the real desktop experience, because we had a different UI just for the ARM-based image and such. So we didn't have much of focus on what we actually were trying to build at that time. And as I said initially, the lack of support for cross-compilers. There were no cross-compiler in the archive itself. We were kind of unable to cross-compile any package. It was just, if you wanted to try to cross-compile it, you would do it in your own way, like downloading the cross-compiler from Code Sorcery and trying to cross-build the package with XDeb or any other tool that you would like to use. But it wasn't supported at all, as kind of officially supported at least. Any kind of enablement that we need to do was also tied with a lot of different development efforts that we need. Like, for example, for the bootloader, we started using Red Boot initially, I think, for X51, and then we switched it to Ubuntu. We tried to do software bootloading with KSAC. We tried to experiment with a bunch of different solutions. The kernel, as I said already, like maintaining the BSP kernel and doing the forward-porting and the security fixes, and integrating for example, we also didn't want to just ship an image that would basically boot without any acceleration on the ARM board, because then it would feel pretty slow, and you wouldn't actually be able to access any other of the advantages that we have on ARM, like, for example, good video decoding support, GLES support, and things like that. So everything that we wanted to support on that, we would need to carry as a binary blob, and we needed to carry it over once we update the kernel and things like that. So a lot of development, we needed to do a lot of development to just get things to work. And a bunch of toolchain fixes, like when we started porting for most of the packs for Thumb2 support and even Eon, there was a bunch of ICEs that we got on the compiler, and so we also needed support from the ARM. From some ARM engineers who helped fixing most of them. So there was a lot of development going on, just basically to have something useful for people to start building products and start using it. And something that was pretty hard to deal with is that we're kind of the second-class citizen in Ubuntu as well. So we had it kind of unofficial, but it wasn't official enough. Like, it wasn't the same. We didn't have the same benefits from, for example, from X86 support. And the ports was a different repository, didn't have any mirroring, and a couple of other things that we had initially. So it was pretty hard at that time to work with, improving it and doing the releases. But then Linaro showed up, 2010. It was announced at Icomtex, and then one of the major focus was trying to fix this whole ARM ecosystem and try to mostly avoid fragmentation, and then for example, this whole development effort that you would need to do on your own distro to kind of a common place, so everybody could just jump in and use the things that we produce, that Linaro produces, and just basically integrate the deliverables in the distribution itself instead of just having all the distribution to do their own development. So one of the key things initially was to have like a huge work on the kernel side to try to work with the different vendors to at least forward-port stuff to the same kernel version and try to work a little bit, trying to come with different platforms, with common architectures and common codes and support, like, for example, PMAX and a few other things. Also, a good place to work on optimization on the latest ARM targets that we had and we supported at that time. Like, for example, ARM v7, Cortex A8, and 9. There was as I'm going to show, one of the things that we did is on each different area. Like, for example, multimedia, graphics, and Toolchain and such. We had something that would be useful that would be good to optimize and improve it. And the goal here was like to be the single point for most embedded developers and distributions. So when they wanted to support a new board and a new target, they would just come to Linaro and get all the latest kernel support, for example, Bootloader, Toolchain, and for example, multimedia optimizations and such, and just basically integrate that downstream. So like Linaro would be kind of the kind of upstream development for embedded development in ARM in general. So then we started Linaro, and we had a bunch of engineers working on a bunch of different projects, trying to optimize things, trying to improve things around. But we needed a reference platform to be working internally and also to show people the work that we were doing at that time and actually prove that some optimization, some work that we did was actually useful for people to consume. So then we started with one of the goals that we also started discussion internally was we needed something to present, we need something to show to people, and also at that time we started the validation lab. We had Lava, and Paul Larson is going to talk a little bit more about Lava later on, but it would be like testing system. It's like testing framework system, but you do all the scheduling for different boards and run tests and things like that. So we also needed a platform to be used at that internally to use as kind of the master images for all the boards that we had. And we also need like a reference platform to be used during the development, like because when you're trying to improve, like for example, let's suppose libjpeg turbo, ffmpeg libav or anything, you would need something to work on top of it, something to work on top. So then we started focusing mostly on trying to build a common and generic Linux platform, because we also had a bunch of development going on the Android side, but at that time, most of the developers that we had involved with Linaro was kind of used with the generic Linux platform, because it was basically what they were kind of used to work on their own laptops. And also before, like even with Open Embedded or any other distribution that they had, it was kind of not tight, for example, with Android or any other solution. So it was a lot easier to just select one common generic Linux platform to be used internally and also to present people. So then we took Ubuntu as our main developer platform. And for a few reasons that basically something that I presented before was like it was already supporting and focusing on the newer ARM devices that he had at that time, like for example supporting ARMv7, optimizing for thumb and things like that. And it was also something that Linaro wanted to do. I mean, when Linaro was built, Linaro wasn't planning to optimize and improve support, for example, for ARMv5, ARMv6, and things like that, but more like thinking about the future and improving like the latest available architectures, like ARMv7 at the time, and nowadays like Big Little, ARMv8 is going to be happening in a few months, and A15 and new architectures. And I think at that time we had thousands and thousands of packages already available at the archive. I don't remember, it was 20K or something, or even more, already compiled for ARMv7, so it was a pretty good start already if you want to do development work and improvements and such. And we had on the Ubuntu side, they had a great relationship with ARM because of the whole effort that need for the 2004 release to do this whole fixes and development on the toolchain side and the packaging importing and such. So it was quite easy to work with ARM, and ARM was kind of used to work with Ubuntu. So it was very easy to actually, and ARM was deeply involved with Linaro since the start, so it was pretty easy to just select Ubuntu and then go for it. And at that time, it was already the most popular Linux distribution, so we want to use something that was also, that people would like be asking already and trying to use and things like that. So for example, we had the option to support Open Embedded and for example, Fedora didn't actually had a good ARM support at that time. But we had a few other distributions that we could start supporting, but we knew that everybody would be looking for the most popular one to actually use and play it internally or do development on top of it. So it was also a good reason to select Ubuntu at that time. And we had the opportunity as well to move some key developers, the key Ubuntu developers from Linaro. Because Linaro had a partnership with Canonical, and then a bunch of core developers from Ubuntu was also available for Linaro since the day one. So it was pretty easy to do any kind of major change on Ubuntu as well. And as I said already, it was always focusing on the latest and greatest hardware without actually worrying too much about the old, for example, ARMv5 and ARMv6. And so a couple of goals that we had initially when we switched and we selected Ubuntu as a platform that we would be working on, and was basically we had a pretty good support for a bunch of boards already, like for example Beagle, Freescale, X51, and Panda board later on. But we also wanted to extend the support for other platforms because on Linaro, the way that we work, we had this big partners, like for example Samsung, Freescale, ST Ericsson, and TI, and we want to provide them the support for this platform as well. Like for example, even for Ubuntu, but also on Android that we started doing a little bit later. We also wanted to fix this whole cross-compilation thing on Ubuntu and try to make it a reality, like bringing both the cross toolchain and also enabling people to cross-build the packages. Because I know that ARM is pretty fast nowadays and have pretty strong CPUs, but if you're planning to compile, for example, Qt or LibreOffice, you know the pain that is to build it natively. Like even on a Panda, it can take plenty of hours. So cross-build is still something that we're going to need and use for a couple of months and even years, I believe. So something that we would like to fix as well. And for Ubuntu, Neon optimizations in general wasn't that important. It was something useful, but as it wasn't like a requirement, the engineering team wasn't looking so much on optimizing things for Neon. But Neon was a kind of a goal for Linaro because we wanted to push the most we could from the platforms that actually supports it. So not Tegra 2, but any other, for example, the ST Ericsson one for the boards that we have now is Snowball, Panda board, Map4, Origen, and a few other boards that we have. Those also supports Neon by default, so we wanted to optimize it the most we could. And I also wanted to provide the full enablement for all the different pieces that the board would support. Like, for example, from the device drivers perspective, from the 3D acceleration, improving things for OpenGL ES2, because it had a support for it, but it wasn't that common across applications. Hardware video decode for people to use, for example, now that we kind of finished the build, like for XBMC, Ubuntu TV, and some other things that people might want to build on top of it. Compiler optimizations, that was also one of the big targets for Linaro at that time, because the whole, before Linaro started, we had Code Sorcery doing most of the development work for the toolchain. But it was a little bit slow in a way that it wasn't actually fully supported upstream. It was kind of a little bit hard to work with Code Source because of the business model and things like that. So we want to push the most we could on and optimize the most we could and try to make it available upstream so the faster that we could. So there was also one important error for us. And summarizing a little bit the work that we did, we started using Ubuntu and started development on top of Ubuntu, but working against the development release is a little bit hard because things tend to break very often. So one of the things that we decided initially was to build what we call as the Linaro evaluation build based on Ubuntu. That would be based on the latest stable release available, and we would do all our development and optimizations and such on top of the stable release, and use and produce these Linaro evaluation builds as a kind of experimental place that you could just basically be worried about your own feature and own development. And once you get it working and you prove it and you show to the people, we can start trying to push it upstream and try to push it to the latest development release. So once the new Ubuntu release is out, it would also contain the optimizations done at the Linaro evaluation build. And I'm going to talk a little bit more details about all the whole topics that we had, but we had a bunch of engineering going on from the Toolchain, graphics, multimedia, the core of the distro, kernel, bootloader, and a few other things that is my interest in you as well. Going over the improvements that we did. First, the Toolchain. This was actually a pretty big thing for Ubuntu. We started the Toolchain working group since Linaro started, and we tried to push all the ARM-related changes and fixes and produce a branch, a development branch as well for people to use. And meanwhile, we're also trying to push upstream. So we started producing what we call as this Linaro Toolchain, Linaro GCC, and a few other important pieces. That kind of is a little bit ahead of the upstream at that time. So most of the things, we also tried to do some kind of backporting as well and improvements. So would be like the best toolchain available at that moment if you want to get the latest stable and latest optimized one for ARM. So one of the major things that we decided to do in Ubuntu is to get this toolchain optimizations that Linaro was producing, but not only for ARM. We decided to push this by default across all architectures, even if it is the development that Linaro is doing is mostly ARM related, but we also wanted to make sure that it wasn't breaking the other architectures, and Linaro kind of agreed that they would also help to fix any issues that would be affecting in the other architectures. So it was a pretty big change because it's pretty intrusive. So if you had any issue with it, it would also affect the whole other architectures, and even the x86 that was the main one for Ubuntu. So now the way that we do is until the feature freeze, like for example, precise pangolin, we had a feature freeze, I think it was yesterday. And it's basically in the middle of the development. And until feature freeze, what we do is we get all the monthly releases from Linaro toolchain working group and pushes directly to Ubuntu. So once it was released, I think it is in a matter of 1 or 2 days is also going to be part of the Ubuntu once the development is pretty open and before the feature freeze. After feature freeze is a little bit hard to push this kind of changes. So what we try to do is basically help with bug fixing and backporting if they are important enough for Ubuntu. And then once the new cycle is opened again, we switch it and start using the latest one available. And some other thing that was actually pretty good. And nowadays, I think once we started, one of the main common questions that we had is like how to cross-compile the kernel and how to get a cross-compiler, how to download it from the code source to install and things like that. And nowadays, it's pretty easy. It's what we did is we started to producing the cross toolchain based on the native one. There's a bunch of scripts that Marcin is maintaining on our group that basically gets the native toolchain and produces a cross toolchain on top of that. So it's basically the same code. And it is also available by default nowadays on the archive. So if you want to cross compile, you don't even need to download external toolchain, for example, for code sourcery or anywhere else. You can simply just install with apt-get, and it would be the most optimized and working toolchain that Linaro is working on. And it was a pretty good change because nowadays it's pretty easy to cross-compile the kernel any other tool that we have without any extra steps. Now for graphics, this was also one of the most hard areas that we decided to work, because at that time OpenGLES was supported in a few libraries such as Qt and EFL, but wasn't enabled by default. So as we started the ARM-built Ubuntu based on Debian and also getting the changes that would also be effective for all architectures, we didn't have any OpenGLES 2.0 support kind of out of the box. Most of the packages that would support it, you will need to change it as a compiler time decision to enable the OpenGLES, but that wasn't. But at the time we had switched it for, we had it selected for OpenGL only across all the packages. So even, for example, Qt and EFL that had a good OpenGLES support, it wasn't actually enabled for ARM. So something that the first thing that we decided to do was to change all the packages that had OpenGLES support and change it at build time to behave it differently on ARM. So nowadays, for example, if you grab Qt, EFL, and also a few other important toolkits and libraries that supports OpenGLES, would basically use OpenGLES on ARM by default. If you have the drivers, of course, it will be accelerated. If not, it will be provided by Mesa. And a few other things that we improved is the Mesa utils. Now, for example, you can have the same tools that we usually support, that we usually use on x86 with the OpenGL, like for example, yes2 info, yes2 gears, so we can easily test and grab the information from the OpenGLES board that we have available on your ARM target. One of the big things that we announced that I think a couple of months ago was the Unity 3D support, just to bring kind of the same experience that you have on your desktop, so people could use it in the same way that we were also using for x86. So we needed to do a bunch of porting and fixing on not only Unity, but Nux, that is one of the toolkits that are used by Unity, and Compass as well. Compass is still work in progress. We have the packages and support available for OpenGLES, but it's not yet upstream. There's a lot of work going on that area because it's pretty hard to push this kind of changes there because you could easily break the x86 support. And as Unity is kind of the main interface and it also uses Compass on x86, if we break it, there's going to be a lot of trouble. So there's still a lot of work going on, and we hope to push the changes upstream probably on time for the next Ubuntu release. And a bunch of other areas that we're working on is to provide benchmarks for people to use with OpenGLES boards and cards, because I think Nokia was mainly the first, when they started building Maemo and later on Beagle, they pushed a few, they created a few projects to enable benchmarks so they could test across the development, across the product development to see if the performance was going well, if it was improved or decreasing and things like that. But we also decided to do a few improvements on that area and provide a few others benchmarks for people to use, because nowadays we are supporting not only one single board, as Nokia was mainly worded for map3 at that time, but also supporting different boards, for example, for Samsung, for ST, TI, and such. So we want to provide one benchmark that would be useful for all of them, so we could compare, we could see how well it is performing and things like that. Another area that was also pretty important for us to make it available in Ubuntu was, and to prove it in the Ubuntu support, was the multimedia. I think Ubuntu and Debian as well was one of the only distributions that didn't actually switch to libjpeg Turbo at that time when we started the project. So what we did is there was a lot of work comparing and benchmarking and make sure that it was ABI compatible. But now we are glad to say that libjpeg Turbo is finally the default libjpeg provider in Ubuntu. So, and this affects not only ARM but x86 as well. So because it could use any CD instructions, like for example MAX and a few other instructions that will also be fine on x86. And for ARM, it would be basically using Neon to improve the performance a bit. And if you compare the graphics between the old libjpeg and the libjpeg Turbo, you'll see that the libjpeg Turbo is a lot faster. So, and it's ABI compatible, so there wasn't a lot of troubles to making it available as a default. Another thing is we wanted to push this new ELCE UCM support across the boards because it was pretty a mess when talking about sound support. Because you had you implemented the sound support on the SoC level in the kernel, supporting all the channels and all the options that the board would give it to you. But then when you had a final board, like for example a Panda board or a Blaze, for example, from Map4, and on Map3, Beagle, IJAP, and whatever other board that we might have, they use it the pins and the configurations differently from each other. So it was pretty hard to maintain those because we didn't want to push all the support in the kernel side, because then we would have a lot of duplication. So one of the things that we decided to do was to start using ELCE UCM and move all this complexity to the user space. So at the user space, we have different configs for different boards that would set up the mixer correctly, and so then you could have only one single support for the SoC itself and the kernel, and everything else you just leave it to the user space. And we started shipping out also UCM support in Maverick, and improved it a little bit on Oinerk. And we also, for the LIBs, we're also providing it for MX53, but we plan to push across all the boards that we have. So it will be a lot easier to maintain later on. And for a map itself, there was a lot of work going on to improve the DRM support. For example, when you boot a board, you can grab the ADAD from the monitor and set up the correct resolution and do the KNS and then set the frame buffer correctly. So it was kind of I think the first ARM target that we had that was fully supporting the DRM as we have on x86. So there was a pretty good thing and pretty nice thing that we push it on by default. And something that we are still a work in progress is the definition of a common EGL image extension to enable texture streaming that would also work with EGL. So you could do the video decoding, and then you could just push it as a texture and then manipulate it and compose it in the way that you would like on your own application. And we have one sample implementation for OMAP at the LAB. We're trying to work with the other vendors and try to make this in a kind of official extension with Khronos. But if you grab, for example, our current XBMC and Ubuntu TV images that we provide as the LAB, you're going to see that is using the AGL image itself already, and you're going to see that it's pretty fast and pretty easy to use it. For example, you could easily build a KML-based application with Qt with a few lines, and you could manipulate the texture the way that you like, and you still have 1080p video decoding support. So it's a pretty nice thing, at least from the designer point of view, people are actually building products. On the core part of the distro, a couple of things that we changed is we started working heavily on the multi-arc support. There's going to be a multi-arc talk that Wookie is going to do, I think, later today. So you can go to the talk to understand a little bit more how it works. But basically, to enable different you to install different packages from different architectures in the same root FS, and that would basically be used a lot. It would be used and important for the cross compilation, because even on x86 you could install all the ARM-based libraries on the same root FS and cross compile the ARM package, and it would look automatically for the ARM-only libraries instead of hooking up with your own system. So it's pretty neat. It's pretty nice, actually. And if you want to get more details, Wookie's going to present it later on today. Also, something else that Wookie was working on is the cross-BUD support that would basically use multi-arc to cross-build the packages. And what we currently have is we have a cross-BUD that is watching keeps watching the Ubuntu archive, and once a new package is pushed to the archive, we download it and try to cross-compile with the multi-arc, and then we report the result to see if it is succeeded or not. And that would also, and it is also useful for the Ubuntu developers and Debian developers as well, because then they could help porting the packages and fixing all the packages that doesn't work well when cross-compiling it. As I said already, we're providing the Ubuntu LAB based on the latest stable release. We also provide what we call the hardware pack for all the flavors that we have, and it's a pretty good thing and easy to work with, because we provided the Ubuntu desktop, for example, rootfs without any hardware-specific thing on it, and then you just grab the hardware pack for your own board and flash it on an SD card or even on the board itself, and that would basically get from the hardware pack all the kernel, the bootloader, and pieces that are specific for a board, and then you have your final image in the end. So we don't need to produce hundreds of different images. We just need to produce one rootfs and different hardware packs for each board that we support. There's also some work that we do on the ARM porting level. Once we started to support ARM as an official target for Ubuntu, we got hundreds and what we call is the fail to build from source, because for example, a package that is not compatible with ARM, there's an alignment issue, for example, when building it, and a few other ICE, for example, issues on the compiler level. So we try to have this web page that you can see the whole status and all the packages and all the bugs that we have across all the packages. So that's something that we try to fix, and I try to improve the support itself, and most of the time it also goes through upstream. So later release can also be available and working kind of out of the box without any custom change only for Ubuntu or Debian. There was a lot of work going on this cycle to enable ARM ATF build instead of using softFP. We're now trying to deliver only hard float by default. So that is a pretty good thing, because it actually accelerates quite a bit in a few free use cases, and you can still use the same board that you had in the past. So it will basically just improve it, and you get a better experience for it without actually changing anything on your hardware. And something that I don't know exactly why we didn't use it in the past, but I think it was basically because the compiler wasn't stable enough. But that's something that we're also planning to use. And I think what we're trying to deliver on the next Ubuntu release is basically ARM ATF by default across all the boards that we support, and stop providing ARML. And a couple of changes that we did on either on the kernel side, on the bootloader side. From the kernel side, we, for example, for MAP4, you're going to see our optimizations and changes that the TI landing team in Linaro did. For MX53, we are providing the kernel package itself based on the Freescale landing team. And we're also pushing additional support for all the other boards that we have, like, for example, Snowball, Origen, MX6, and such. Because each landing team provides their own kernel tree for that specific board. And then what we do is basically we package it up and try to push and make it available in Ubuntu as well. And there was a lot of changes that we also did on a bootloader level. Like, for example, we wanted to get rid of Xloader and finally replace with Ubuntu SPL, so we did some work on that side as well, and finally able to switch it all, for both MAP3 and MAP4. USB booting with Ubuntu SPL, something that you can grab on the latest Ubuntu Linaro. You can, for example, on your Panda board, you can just plug in the cable, and then you can. There's a tool that you write the SPL. And then Panda board, you get the SPL and boot it, and then download the Ubuntu, for example, from the SD card or any other place that you might have. And there's also something that was pretty kind of a requirement from the server team and Ubuntu is that to have PXE and TFTP working out of the box, either for Panda board and other flavors that you had, because on the server side, you want to easily install the distribution from the network instead of doing the whole and traditional install. And as I said, additional different support for all the different boards that we have available for our partners. And talking a little bit quickly about the future development, something that we want to do and we'll keep doing in the next cycles is finish the porting for and enabling for MHF. And we're going to be probably making it as the default one for Ubuntu Precise. But we also need to do a few more work on that level. For example, I know that there are people working on Haskell and LibreOffice and Ruby and a few other pieces that are not yet fully available for MHF. So we're still trying to fix that. Ubuntu ARM for servers, that kind of a requirements nowadays is to move it away from a little bit from Ubuntu, but actually provide UEFI and a Grub2 interface to be kind of common across architectures. Beagle is going to be a big thing in a couple of months. How we optimize it, how we improve it, and on the distro level, what we can do to also use it the most we can. And one of the most interesting from the server perspective, the V8 is what we call the 64-bit ARM architecture that's going to be coming in the next few months. So that's something that we're probably heavily working on in the next few cycles. And on our side, what we're trying to do currently is try to enable the continuous integration for all the changes that we do. We kind of produce daily images and try to validate it because then every development that Linaro produces, in the end, you could easily just grab the test results from that specific development, that specific snapshot, and see if it worked well or not, and then decide to grab it and integrate your own distribution, for example. And a few other requirements that may come from, for example, from Ubuntu, is like the Ubuntu TV, tablet, car, and phone, and a few other interfaces they're working on. And it's something that we can do, and we are planning to do in Linaro, is to optimize the toolkit and more like looking at the middleware and see what we could do to improve it a little bit. And for example, for Qt, how to improve Qt mobility, and improve any other middleware tool that might be useful for these kind of applications, so they don't suffer when they choose ARM they choose to create a product on top of that technology and using ARM. And one work that we've been doing, I guess, for quite a few months, and we'll still be pushing, I think this year and probably the next one, is to try to have one single Z image to rule them all, as I said, to build all across the boards that we support. And so then we could have the kind of the same experience that we have on x86. And instead of maintaining different binaries from different trees and such, we have only one single tree and one single binary that could boot and work on all the ARM boards that we are officially supporting. I guess that's most of it. I think my time is probably ending now. So just open quickly for questions. I don't know if you have time for questions, but if not, somebody will interrupt us. So any questions? Yep. I don't know if you want a microphone or can you?
I'm curious if right now the Android and Ubuntu kernels that you're supporting, say for OMAP, are significantly different. I'm a little bit confused in your talk. Sometimes you're talking about Linaro and sometimes you're talking about Ubuntu, and I'm not sure what features exactly are included.
Then we to set up a little bit about how we're working on the kernel side from Ubuntu, Linaro, and the Android perspective. Is what we do is we have the landing team, for example, the TI landing team working on improving the kernel itself and trying to deliver new features and enabling that tree. And what we do on the Ubuntu side, we just add the packaging sauce, as we say, on top of it and provide it to Ubuntu. But for Android, I think they're still maintaining a couple of changes off the tree. So what the Android team is doing is taking this tree from the landing team and doing the Android-specific bits on top of it, and then also shipping on the Android. So what we try to do is the landing team is kind of the common place if you want to go and to have the best available kernel for a specific board. But then what we are doing for both Android and Ubuntu is just basically adding the needed sauce on top of it to make it available for people.
Are there a lot of Ubuntu-specific packages that aren't generic to the kernel as well, or not?
There are a couple of things that we support from Ubuntu, like to make it a kind of official Ubuntu kernel, we need to enable a few options. And for example, I think there's also a few sauce that we get from the Ubuntu kernel team. Is, for example, AP Armor and a few other things that they are usually supporting, and a few other fixes for security mostly, but they're not that intrusive in the kernel side. So it's more like a packaging sauce and a few other things that will just basically to fit the Ubuntu's need on a user space level. So, I guess our time is out. I've been interrupted, so thank you very much.